Python Pandas is an imported library used to organize, analyze, and manipulate data. It is useful because it makes it easier to work with large amounts of data, calculate statistics, and sort and organize data. To use Python Pandas, first we need to import the Python Pandas library. To import the library, we write import pandas, and to shorten the name, instead of writing pandas over and over when we use different commands from the library, we can shorten the name just to PD by adding as PD. Next, we need to create a data frame. A data frame converts data into a table-like structure. For example, on the slide over here, we have a dictionary because of these curly brackets, and the data inside of the dictionary. So we have fruit data, we have price data, and we have stock data. And what a data frame does is that it takes data like this and it turns it into a nice table format. So we have a column for fruit, a column for price, and a column for stock. So here we have our basic data again, which is fruit, price, and stock. And to turn this data into a data frame, we would write df, which stands for data frame, is equal to pd.dataframe, and then the data that we want to turn into a data frame inside of the parentheses. To display the data frame, all we need to do is print the variable that the data frame is stored in. So in this case, df stores the data frame, so all we need to do is print df. Now when we run our module, we see that our data frame is printed. To print the first few rows, type df.head. So what df.head does is that it prints the first 5 rows. So if I were just to leave it like this, df.head would print 5 rows. Since our small data frame doesn't have 5 rows, it just prints all of them. But now inside of the parentheses, I can type how many rows I want to see. So if I wanted to see 2 rows, then I would write inside of the parentheses 2. When I run the module, then the output is only the first 2 rows. The same thing happens if you want to see the last few rows. But instead of head, we type df.tail. Without any numbers inside of the parentheses, it would print the bottommost 5 rows. Since our data frame doesn't have 5 rows, it just prints all of them. But now, if I type 2 inside of the parentheses, the module should output the last 2 rows. And it did. These are the last 2 rows of our data frame. Now to get information about our data frame, type df.info and then parentheses. What df.info does is that it gives you column names, the number of rows, missing values, and data types. When we run our module, we see this output. So what this shows is that there are a total of 3 columns, and the columns are fruit, price, and stock. All of these don't have any missing values, and the column of fruit holds the data type of strings, the column of price holds floats, and the column of stock holds integers. To select one column, type df, then square brackets, and inside of the square brackets, write the name of the column that you want to select. When we run the module, we see that we get the output of that column. So since I wanted to select the column fruit, we got all of the fruits inside of the data frame. And we also have the column name and their data type, which is strings. Now to select a row, type df.iloc and then square brackets. Inside of the square brackets, type the row number. So if I wanted row number 2, then row number 2 holds oranges. So we see the fruit is orange, the price is $1.50, and there are 15 oranges in stock. So the name of this row is row 2, and then the data type is an object. To select multiple rows, say if I wanted rows 0 to 2, then I would write 0:3. so the last row doesn't get included. Now if we run the module, we see we have row 0, row 1, and row 2. For example, if we wanted to get all of the prices that are greater than $1.25, we would first select the column of prices, and then we would look for all the prices that are greater than $1.25. This all now gets stored into a variable called expensive. So now to create a new column, we first write df, then square brackets, and inside of the square brackets, our new column name. Then that is going to be equal to the data that the column holds, which in this case is all the prices greater than $1.25. Now if we run the module, we see that we have false, false, and true, true. So what does this mean? If we look at our data frame, which is right over here, we see that the price is $1.25, then 75 cents. These two rows are marked as false, and that's because they are not greater than $1.25. But the next two rows are greater than $1.25, which is why they're marked as true. To remove a column, we write df.drop and then the column name. So now when we print our data frame, we see that we are back to 3 columns. To get all the unique values in a certain column, first we need to select our column, which we do by typing df, and then our column name. Then we do .unique and parentheses. So that line outputted the 4 prices that are already in our data frame. This is because we only have 4 unique prices. Now, to find the amount of times each unique value occurs in a certain column, we again select that column, and then instead of unique, we write value counts. Here we have our 4 prices again, and each of these prices occurs exactly once. And that's it. Those are the Python Pandas basic commands. In my next video, I'm covering a more complex example of using Python Pandas to analyze a UFO dataset.